When we think of a solution, we usually think of a liquid like salt and water. But solutions can also be gases like the air in our atmosphere, or even solids like steel, which is a mixture of metals. In this chapter, we'll focus on liquid solutions, particularly solutions of ionic compounds. Solutions are comprised of two components: the solvent, normally what's present in the greatest amount, and the solute, or the substance being dissolved. Solutions form when one substance disperses uniformly through another. The dispersion occurs because of intermolecular forces between the solute and the solvent particles. With sodium chloride and water, we have ion dipole attractions. Very polar water molecules are able to overcome the attraction that sodium and chlorine have for each other, a process known as solvation. When nonpolar substances dissolve, London dispersion forces are at work throughout the solution. When sodium chloride dissolves in water, it's because the negative end of the oxygen molecule is attracted to the positive sodium ion, and the positive hydrogen end of the molecule is attracted to the chloride ion. In order for solvation to occur, energy is needed to pull the sodium and the chloride ions apart, just as energy goes into moving the water molecules apart to make way for the ions. This diagram shows us the energy changes that are associated with solvation. The first change in enthalpy happens when the liquid solvent molecules start to move apart from each other. The second enthalpy change occurs when energy goes into making the solute crystals, for example, the sodium and chloride ions, also move apart. And since both of these processes require energy, they're both endothermic. Once the new solution has formed, then energy is released. And so the third part of the process is going to be exothermic. The overall enthalpy change for formation of a solution is determined by adding these three enthalpy changes together. And depending on the magnitude of each of them, the overall process could be endothermic or it could be exothermic. Ammonium nitrate is a nice, orderly solid. In the dissolution of ammonium nitrate in water, more energy goes into the separation of the components than what is released on the formation of the new solution. So the overall process is endothermic. That's how cold packs work. Inside here, there's one compartment that's filled with ammonium nitrate and another compartment that's filled with water. And when you break the seal between them, they mix up and form this solution. And since this process is endothermic, meaning more energy has gone into the separation of the particles that gets released when the new solution forms, then the cold pack feels cold as it's pulling energy or heat in from the surroundings. And the delta H for the process is 26.4 kilojoules per mole. Note that it has a positive value. It's an endothermic process. Adding magnesium sulfate, better known as Epsom salts, to water is an exothermic process with a delta H of negative 91.2 kilojoules per mole. In this case, the energy needed to rearrange the particles is less than what's released upon the formation of the solution. In the introduction to thermochemistry, we learned that exothermic processes tend to occur spontaneously or are thermodynamically favorable. Endothermic processes, not so much. Octane is a component in gasoline. It's a hydrocarbon, so it's a nonpolar molecule. Sodium chloride won't dissolve in this nonpolar molecule because the electrostatic attractions between the sodium ions and the chloride ions are too great. They have too great of an attraction for each other to be attracted to the nonpolar octane molecules. That's why we say like dissolves like. The stronger the attractions between solvent and solute particles, the greater the solubility. We said exothermic processes are thermodynamically favorable, but we did say that this reaction happens spontaneously and it's endothermic with a delta H of 26.4 kilojoules per mole. So there's one more piece to consider, and that's entropy, which is the randomness or disorder of a system. And since our ammonium nitrate goes from a nice ordered solid to a very disorderly solution, the entropy of the solution increases. And processes that increase in entropy tend to also be thermodynamically favorable and are said to occur spontaneously. And one final note to consider. The formation of a solution is a physical process. The solute and solvent can be fairly easily separated. Don't confuse this with chemical reactions where a new product is formed.